Let's see if that works. Let's talk more about open source, and let's talk about Postgres. Okay, I'm talking about WarehousePG today. I was supposed to be here back in October, but I had to cancel, so thanks for inviting me again. My name is Andreas. I'm mostly working with Postgres, which you may or may not can see, for almost 30 years now. I'm one of the founding members of Postgres Europe Board of Directors. I did run in a couple of companies, and now I'm working at EDP as a principal engineer, almost exclusively on WarehousePG. So, if you want to follow me, your best chance is actually my Mastodon account. You may also find me on LinkedIn. And I will write about this meetup on my blog. Okay, but what is WarehousePG? Anyone heard the name before? One. Ever heard about Greenplum? A couple more hands. Ever heard about Postgres? It's all the same. Okay, I will show you what WarehousePG is. I will also explain what problems it solved and why it has a reason to exist. And what the main reason for this talk is, why did we make it open source again? Why was it not open source in the first place? So, we talk about analytics exclusively in SQL databases. WarehousePG is a massive, parallel, shared nothing, open source SQL database. Lots of buzzwords. Massive parallel means, okay, we have plenty of resources somewhere, we have a couple of servers in a rack, and we operate a couple of databases on each server, and they all somehow work together. And we coordinate this. Shared nothing means all of these different servers we have don't share any hardware with each other. So we have like 4 segment servers here, we call them segment servers. These are just off-the-shelf servers you have in a rack, nothing special. On each of the servers we run more than one Postgres database. So each of these icons here is a Postgres database. Between 4 and 12, depends a little bit what workload you have. And then we have one extra box at the top here, we call it coordinator. This one doesn't have any data, it only has the metadata, so the catalog for the entire database. And all the data lives sharded down here, sharded across all of the boxes we have. All of this is Postgres. Each of these icons here is one Postgres database. We have 4 here, the coordinator is one. They all talk to each other, and you as a user, you don't talk to the segment databases, you only talk to the coordinator, and it looks like a Postgres database. There are some minor differences, but in the big picture, you run your Postgres SQL queries again a WarehousePG, and it looks like a Postgres, just very big Postgres database. So it's open source again in May 2025. It's hardware agnostic, so the boxes you see, the servers you have, there's nothing special in it. Go to your preferred vendor, buy a server, plug a network cable in, and you're good to go. You don't have to go and buy like 5 years ahead or 3 years ahead some hardware. You can just scale this out. And it's SQL database, so it's mostly what we're doing. Postgres is fully SQL 92 compliant. We have plenty of features on SQL 99 and then quite a few from SQL 23 standard. Postgres is a bit far ahead, but I'll talk about this in a moment. Okay, we are not the only one, of course. There are plenty more. There's of course Greenplum, so we forked from Greenplum. There are more forks than WarehousePG. There's one in Russia called Arena Data. And there's the Cloudberry project, which was forked in China. It is now an Apache incubator project. I won't talk about this too. Go and look up the GitHub repositories. Anyone of you heard about Teradata? That's probably the first shared nothing database ever in the market, since the late 70s, last century. Maybe there's another Postgres fork, Verticas, made by the same guy, Redshift, Snowflake. It's all the same structure, so it just shows that this shared nothing, doing database as a shared nothing architecture, is well established. People are using it across the board. Okay, but what problems do we solve with this? For those of you who have Postgres, what's the largest database you have? Give me some numbers, please. Don't be shy. Gigabytes, terabytes.
We have 150 terabyte one.
50. That's a solid number. Okay. How many people do manage this? Is it a single Postgres database?
Well, it's Aurora, so does that count?
Okay. It's Postgres, but yeah, it's managed. Okay. On a single Postgres database, if you don't have like a managed service, what we typically see is about 10, 15, maybe 20 terabyte, not more. Everything beyond that, it's actually hard to manage on a single server, and people go and find other solutions for this. But what if you have like 100 terabyte or a petabyte? How do you manage this in a SQL database? Yeah, so we see like a terabyte, maybe 10 terabyte, but after this, you actually go and shard your database. So we have several shards here. Each of them is relatively small, but they all work together. And these shards are actually the segment databases we've seen in the picture before. So all you need is basically just something coordinating the work in all of these databases, because you don't want to do it on your own. We are back in the same picture. So we have 1 terabyte here, 1 terabyte here. Suddenly we have like 100 terabyte or so. What if that is not enough? Well, traditionally, if you have like a data warehouse, you had to go and buy servers for the next 3 years. You had to go to finance department. Okay, give me enough money to buy servers for the next 3-4 years, then we do a migration, etc. In this picture, what you can do to just add a couple more servers when you need them, redistribute your database once, and you're good to go with more servers. So there's no need to buy hardware today for the next 3 years. You buy what you need in 6 months. A lot cheaper, you can spend your money in other places. Okay, let's skip over this part. So what sizes do we solve? Anyone know what this number is? It's actually, it's a single table and a petabyte data here. So I built this one last October actually. So some of our managers wanted to see, can we really do a petabyte? Well, yes. This is on 6 servers at Hetzner. Each of them has about 250 terabytes of data in it, but yeah, petabyte, easy to do. If we would have a need for more performance, well, we can go back and say, okay, let's add a couple more servers, because then we get more CPU resources, we get more RAM, we get more disk, we get more everything. So we can spread out the actual workload we have and just get more performance. If you need more disk space, get me some more servers. We spread out. So if a company is growing, you don't have to wait 3 years. You can just scale as you go. Okay. It is a SQL database. It can do OLTP, but please don't use it as your OLTP database. It will be slower. You have certain overhead for all the coordination in your database. So every query you run is actually 2-phase commit in your database. It will work. You just will never see the performance you have in a pure Postgres database. Okay. Let me skip that part because I'm told we don't have so much time. We can pull in data from many other data sources like S3 and external tables. We have an entire framework how we can make data visible inside of our database, which comes from external data sources. We can use this both for querying the data, like we can query aspect data in the database, We can query Lakehouse, we can query S3. We can also query simple things like a CSV file somewhere and just make it look like a table in a database, part of a query. So for the application, it really looks like it's one SQL database, and you don't care what's underneath, how the data is stored, where the data is stored, what format it has. Okay, and yeah, it's open source. We have a couple of machine learning things, so we support PG Vector, we're building PG AI into it, but different story. So why is it open source again? Does anyone know the status of Greenplum?
Is it a property of Broadcom at this point?
It's a property of Broadcom. Ever heard about Broadcom?
Yes. They're not giving it up, I'm guessing.
So, about 10 years ago, there was an announcement by a company called Pivotal. I was working for the company back then, that Pivotal made all of their products open source. One of this was Greenplum, there was Redis, there was a couple more. All of it was open source over the year. Took 6 months, and then at PGCon EU in Vienna, we made Greenplum open source. It's 10 years ago from now. And then, we developed it, and then between 2015 2022, so we got more kernel upgrades, so we aligned with more recent Postgres versions. And then 2022 happened, and Broadcom said we're buying VMware. We all knew this was not going well. 23, Broadcom said, okay, no more perpetual licenses for anyone. You have to buy annual license now. And in May 24, Broadcom said, okay, we are making Greenplum closed source. Any customer of Broadcom were doomed because they had to buy this. We are recording, so I can't really say numbers, but it was expensive. So they shut down all of the GitHub repositories they had for open source. They deleted the entire Slack space they had for open source. All of the mailing lists went silent. It's all done. There was a public source CI pipeline in Concourse CI, which showed what is building, shut down, all gone. Best things they did actually, they cloned the Greenplum repository, left it public, and said it's read-only now. Except there's only one branch. They deleted all of the branches, all of the text, everything. There's only a main branch. You have no history, what release was ever done. You have no history, what was ever released as a product. It's only a main branch. Nice move. Yeah, we have only a single commit timeline. Don't really know whatever is there to support. No text, no nothing. End of 2024, Enterprise DB decided, okay, can we go and support this? A while earlier, another company forked off. It's called CloudPerry. Some of the engineers from VMware founded this company. I already talked the product as a fork when it was still open source, so probably they knew that was coming. It's an Apache incubator project now. Go and look at the GitHub. From time to time, there's some commits. So we had the problem, we have one repository we can't use. What else can we find? There's a couple of other forks of the repositories we have. Questionable sources, we went to legal, and legal said, okay, we can't use it. No chance in hell. We don't even know what's in there. Okay. There is, however, a GPL repository. This was the Greenplum release engineering organization, which also went silent at the same time. What I guess is that anyone who has ever access to this organization left the company, so Broadcom has no way to shut it down. But they're almost up to date, and they have also release and text and everything, which is nice. So we went to our lawyers and said, can we use that? No. But you can go and try to use this repository as a source. Prove to us that it's the same repository and that you can, whatever you're missing as text, import into whatever Broadcom left us here. So we have to use this one as a base, and everything else we can import. It's legal. Well, I know where they're coming from, because they want to tell customers, okay, this is the fork, we fork from this, and not from some other repository. So if we fork from this, we have to use this repository. That's where we have to go. Okay. Well, yeah, we can do this. So we added a new origin, release engineering repo, we imported all of the text, we removed the origin again, and then, yeah, we had all the text imported. Except, no. Because when Broadcom forked the repository and removed all of the text, they also removed all of the code for the text, which is not in main. So there's plenty of code missing. It's about 20,000 commits we were missing in this repository. So along with the tags, we also imported all of the code for the 20,000 commits. So we had to go back to legal. What are we going to do? So we had to prove to legal, beyond doubt, whatever we imported is not malicious. There's nothing in the GPU Welling repository which in some way can backfire to us. Later on, there's some code hidden because, well, I don't want to say anything they're doing, but there's a chance that there's some code in it we don't want to have. So we had to prove this. So we literally checked all of the checksums and all the files against all of the other repositories we found on the internet. And we were quite sure, okay, what we imported in our repository now is actually what we want to see there. There's no hidden code, no Easter eggs hidden, no nothing. This is actually documented, so we documented the entire process. Whoever wants to fork it can go and check this out and reapply all of the steps we did in this. Okay. Now legal said you can go ahead and actually build a product on top of it. This took about 6 months. The entire step, well, we did some more work, but to make sure that there's nothing hidden in it, import all of the texts, build something around it, and actually figure out if this is doable as a product. We can go ahead and then build something on top of it. So we used GPDB archive as base. We imported from the Welling repository. We cannot have a CLA, Contributors License Agreement, because this is with Broadcom. They have all of the CLAs on the original Greenplum code, which also means EDB can never change the license. No way. Which is good. Okay, Broadcom made it closed source. They have the legal rights to do it. If it's a nice move, it's a different story, but they're allowed to do it because they had all of the CLAs. The license by itself, it's a Postgres license, Apache license for Greenplum. The license allowed us to actually go take all of the source code and make it open source again, which is also good, so we like the license. We imported all of the missing source codes and all of the text. So if you go to the WarehousePG repository today, you can see that all of the text are still there. It's all imported now. Project is alive. We hired a couple of the ex-Greenplum people, and we keep contributing to it. We keep improving it. We provide RPMs for this, and the RPMs are also checked for security problems, cloud storage scans, and whatsoever. There's plenty of work done. Pivotal earlier provided also Debian packages. We haven't had any needs to do so if we get a customer who wants Debian packages, we will build it. Yeah, we do all of the black deck scans. We know there are a couple of CVEs, so most Greenplum customers are actually on an older version of Greenplum 6, not on Greenplum 7. It's all running on older Red Hat versions, so we know that there are a couple of CVEs, so we have to make sure every time we release a new version for Greenplum 6, yes, We need to go to IT and security and say, okay, there's an exception. We know about it. That's the things you have to do. We are working on better pipelines. So Pivoted back in the day actually had a very good pipeline for testing, quite expensive. Not all of this is back in play as of now. We're working on backup tools, so there are some basic backup tools in WarehousePG coming from Greenplum, but the good stuff is closed source by Broadcom, so we are replicating this. HA is a big topic for customers, but even so observability. So people want to know what's going on in database, so we're working on that, building products around it. We are also working on kernel upgrades, but this is a multi-year project. Right now, WarehousePG is based on Postgres 12, and we are on Postgres 18 as of today. So we are missing like 6 years of code. And that's not something you can merge in like a couple of months. You need a couple of years for this. And then of course all of the drivers, compatibility, smaller things, bug fixes, etc., etc., etc. Okay. Any questions? I answered some of you already.
Yeah, first of all, this isn't a question, it's just a statement. This is a great talk. Thank you so much for doing it.
Thank you.
Question, how does you had a great architecture picture at the beginning. How does this architecture compare to a product like Vitesse, which also shards? Can you compare those two?
No, not in detail.
Okay, but it's a similar idea because you
It's
got
a similar idea.
you got
yes.
sharded, but are you using row store? You're still a row store, right? Which are sharded.
We have both. We have a row store and we also have a column store.
Mm-hmm.
So you can create every table either by default as a row store or as a column store. Then you get one file per column.
Got it. Okay. Thank you very much.
Thanks for your presentation. So, in the beginning, you were talking a little bit about performance and that you support a petabyte of data. Do you give any benchmarks regarding, in general, the performance of WarehousePG?
So performance is actually a metric of how many servers you have and how much data you have on every server and what CPUs you have, etc., etc. What do you want to compare against? That's the question.
So, my question is more general. Is there anywhere to see for some standard setup that you're having and let's say TBCH queries?
So we
some,
have
performance results.
We did pass, or we do pass almost all of the TBCH queries. We're working on one or two. Same problem Greenplum has. There's no public benchmark. Can go and run a benchmark, but vendors are quite reluctant to actually publish benchmarks. You would also have to document, okay, on what system you run the benchmark, etc., etc. It's rather complicated to get it right. So we don't have any public benchmarks.
And do you have any like runtimes, for example, or something that you maybe tested that you can talk about?
So we test internally for performance, but this is mostly where we get performance numbers for each PR we are doing, and we want to see that we don't do a performance regression. We don't actually test that much for pure performance.
Okay, right, thank you.
I mean, if you want to get more performance in a database like WarehousePG, your typical scenario is that you get a couple more servers and you expand your database, and then this is cheaper than running any kind of large-scale performance optimization. That's what we see what customers are doing.
Thank you for the presentation. First time for me that I talk with a developer of a database. So I'm a normal developer, but I was fascinated by the topic introduced by FoundationDB about testing distributed systems like databases, and I was wondering if you also apply some of the ideas of FoundationDB for testing the correctness of Postgres in distributed fashion.
These are applied, yes. So our engineering is regularly working on this. we have these tests.
Thank you. And it's open source in the repository, right?
I don't know the answer to that. Well, in the end, you get the code, so if we find a problem, we will release a bug fix for it, and then you see that there was a problem, yes.
I was just going to add some color to the 50 terabyte Postgres we had, and also adding context to that comment there. Postgres has a 32 terabyte table limit, so the fact that for a single table. So the fact that we saw 1 petabyte there, that's enough to convince some people to use this. And the reason why we have 50 terabytes is because we hit that 32 terabyte limit. It all broke and we had to copy it to another table. So that still got that, and then we rapidly filled up the one we just truncated. And so it's 50 terabytes, but horribly in a broken state.
So you have 2 terabyte per table in Postgres, but this applies to every partition. So you can have partitioned tables, and then each partition has 2 terabyte. And in my case, this is actually 60 segment servers. Each of them can have a 2 terabyte table. So, makes my life easier. Any more questions?